Okay, today we are going to talk about something called the angle addition postulate. You're going to put this on page 5 of your table of contents. So let's flip to page 5 in your notebook. And let's go ahead and label the top of the page. Alright, the first thing I want us to do is let's define a couple of terms. So whenever I'm talking about the word congruent, no matter what I'm talking about, if I'm talking about line segments, angles, anything, it is two of anything that is the same. Two of the same measures. So if I say congruent lines, I'm talking about two lines with the same measure. If I say congruent angles, it's two angles with the same measure. The symbol for this is an equal sign with a squiggly on top. And I just call that a squiggly. An angle bisector. You will hear me say this some. A bisector is anything that cuts something in half. An angle bisector is a ray that divides an angle into two congruent angles. So basically it cuts it in half. Alright, so we're going to write the name for each of the angles below, and we're going to name the vertex and sides and tell whether it appears to be acute, obtuse, right, or straight. Now in order to do that, we're going to have to define what it means to be acute, obtuse, right, or straight. So first off, an angle consists of two different rays with the same endpoint. The rays are the sides, the endpoints is the vertex. So if we look, this is an angle. These are the sides. That's a ray, and that's a ray. This right here, the endpoint, is called the vertex. Alright, so to talk about the different angle types, first off, if it is an angle from 0 degrees to 90 degrees, got to be in between those. It is an acute. It cannot be 0, it cannot be 90, but if it's in between, if it's from 1 to 89, those are acute. Now obtuse is anything greater than 90 less than 180. So it looks like this. It's a big obtuse angle. A right angle is exactly 90 degrees. And a straight angle is exactly 180 degrees. So it makes a straight line. Okay, so let's look at these angles. I'm going to give you 3 examples. So this is our first example. This is our second one. and this is our third. Pause it if you need me to slow down. Rewind it if you need to hear something else. Okay, so this can be called angle ABC or CBA. The vertex has to be in the middle though. And it is an acute angle because it is less than 90 degrees. This can be called angle DEF or angle FED. And it is a right angle because it makes a 90-degree angle. This one can be called angle RST or angle TSR. And it is obtuse. It is bigger than 90 degrees. Okay? Now, we're going to talk about something very important next. This is called the angle addition postulate. This is important because it is the title of our notes, and this is what you'll be doing a lot of practice on. The angle addition postulate is very similar to the segment addition postulate, but it has to do with angles. So it says that if P is the interior, that means the inside, of angle RST, then the measure of angle RST, and that little M right there means the measure, is equal to the measure of angle RSP plus the measure of angle PST. Now that may not make much sense to you, but I'm going to show you what that means. So if we draw an angle, and it says P is the interior, so we'll draw P right here on the inside, and we'll make a ray that goes with that. It says it's on the interior of RST, so we've got to draw that out. This is R, S is in the middle, and then T is the other one. These two could have been switched, and we would have had the same outcome. So it is saying the measure of angle RST, that's this big angle right here. RST is equal to the measure of angle RSP. So RSP is this yellow angle. Ooh, that didn't look very pretty. Plus the measure of angle PST. So PST is this angle. Now look at that and ask yourself, oh, does the yellow angle add up to be the green angle? That big angle right there? Yes. If you add those two together, they are this whole angle right here. So we're going to have to flip to the back and do some examples. I've run out of room. So flip to the back. Before though, I do like to highlight some of my definitions. So if you want to highlight congruent, angle bisector, angle, and then you could do straight angle, acute angle, obtuse, right, and then the angle addition postulate. Okay, let's do 2 examples. We are going to be on page 6. So the first example is this. We've got this angle is called 3x plus 15. This angle is called x plus 7. And it gives us that A, B, C, so the measure of angle ABC is equal to 94 degrees. And that is point D right there. So we're going to follow the angle addition postulate. So basically the angle addition postulate says this angle, if we take 3x plus 15 and we add it to this angle, x plus 7. It's going to equal that entire angle. So it's told us that ABC was equal to 94 degrees. So we're going to set that equal to 94 and solve. Let's first draw our river, combine our like terms. So 3x plus x is 4x. 15 plus 7 is 22. That is equal to 94. Now we're going to subtract 22. This cancels. We get 4x equals 72. Divide by 4 on both sides. And that's going to give us 18. Now, to find out what your angle measurements are, so that's our x. That is not what the measure of angle ABD is or the angle DBC. That is not 18, because 18 plus 18 would not equal 94. So we've got to take 18 and plug it in for x to find out each angle. So angle ABD, the measure of angle ABD is going to equal 3 times 18 plus 15, and the measure of angle DBC is going to equal 18 plus 7. We just replaced that x with 18. So 3 times 18 plus 15 equals 69 degrees, and 18 plus 7 equals 25 degrees. So those are our two angle measurements, and that's our x. The next example is, this is 3x plus 1. This is 2x minus 6. Sorry, my hand keeps dragging, so it keeps smearing this. Q, R, and T, and S. And it gives us that the measure of angle QRS equals 135 degrees. So QRS, this whole thing, is 135 degrees. So we're going to have to add these two things up and set it equal to the whole thing. So 3x plus 1 plus 2x minus 6. I added those two angles together. I'm going to set that equal to 135. Now I'm going to solve. 3x plus 2x is 5x plus 1 and negative 6 gives us negative 5. That's equal to 135. Now we will add 5 to both sides. This cancels. We get 5x equals 140. And 140 divided by 5 equals, divided by 5 on both sides. X is going to equal 28. So we found one part. Now let's find our two angles. The measure of angle QRT is going to equal 3 times 28 plus 1, which equals 85 degrees. And the measure of angle TRS is going to equal 2 times 28 minus 6. 2 times 28 minus 6 equals 50 degrees. Now if we added those two together to double check us, 50 plus 85, it should equal 135. That is how you could double check yourself. Alright, I hope this helps.